All right, so if you flip to the back of the second page, we're going to do the last problem now. So we got to look for objective 4, the double angle, half angle to verify identities here. Doing this problem here. We got sine of 2, the cosine inverse of negative 1/3. All right. So make sure you're on the right page here. This is the last one we're going to do today. Zoom out a little bit. So go ahead again. Feel free to stop, pause, rewind as needed so you can understand the material here and to get some really good notes. All right. So here, first step. Remember, when we did the inverse function, we're looking for an angle. So let's meet here. Start from the inside, right here. This should evaluate to an angle, right? So the angle, which is theta, is equal to the inverse cosine of 1/3, negative 1/3, right? So we're looking for what angle has a cosine of negative 1/3. To figure that out, think back to the second test. We know that the inverse cosine, the range is between 0 and pi, which is going to be in quadrant 2. And between quadrant 1 and 2, which one is cosine negative? Okay, negative 1/3. Cosine's negative in quadrant 2. So we know that this angle has to lie in quadrant 2. All right. Let's give us a negative cosine. So in quadrant 2, we got negative 1/3. We know that in quadrant 2, we got the x is negative, so it'd be negative 1. And the r is always positive, be 3. So negative 1 and 3. Because cosine is what? Cosine is the x over r, and we got negative 1/3. So the x is negative because the negative x factor here. And the r is 3. So we're going to use Pythagorean theorem to find the y, right? To find the y. So we know that when you do your math here, y equals what? When we find Pythagorean theorem. Y equals the square root of 8, which simplifies to 2, the square root of 2. Because 4 times 2 is 8, the square root of 4 is 2, so 2 square root of 2. Now we got our x, our r, and our y. So we can rewrite this problem. We know that this problem here equals to sine of, why does that? Erase that. It'd be the sine of 2 theta. It would be the sine of 2 theta because theta equals that angle right there, sine of 2 theta. So we're going to use, flip to the front, we're going to use the double angle for sine of 2 theta, which equals to 2 the sine of theta cosine of theta. All right? So this equals, right here, 2 the sine of theta, the cosine of theta. Right? Equal to 2 the sine of theta, which is right here on this side, is the what? Is the y over the r. So y is what? So it would be 2 square root of 2 over the r, which is 3, times the cosine of theta. Theta is what? Cosine is what? Negative 1 over 3 times negative 1 over 3. And then we're going to use some PEMDAS to simplify our expression, right? They're going to multiply straight across. All right? So we get 2 times 2 is 4. 4 times -1 will be -4. So this equals -4. The square root of 2 over 3 times 3 is 9. That's the answer. So we know the sine of 2 the sine of 2 inverse cosine of -1/3 equals to -4 square root of 2 over 9. So again, take your time, go back and rewatch the notes. Ready to look closely to the formulas that we're using and what do you need for each formula to solve each problem. All right. It's going to take lots and lots of practice and trial and error. So do your best. Remember to look at your textbook, look up the LSU videos if you need help. We got this, y'all. We got this.